my name is Dr. M. Salah, Department of Physics, University of Unilorin. I'm here to demonstrate an experiment titled Moment of Inertia. It's experiment 8 in our physics laboratory manual. And the apparatus required are the inclined plane. This is what you are using as our inclined plane. Then the stopwatch. This is our stopwatch. The cylindrical object. This is the cylindrical object. The meter rule. The weighing balance. And the vernier caliper. So, but before going to proper demonstration, let us have a theoretical review of the experiment. And starting from a kinematics equation, in one of the kinematics equation, is S equals to ut plus RVT squared. Of course, we know that to perform this experiment, the metallic cylinder is to start from rest. So because of that, we make u to be 0. So when we make u to be 0 and make S the distance to be equals to L, that is the interval of the journey, then we can have equation 1 can become L equals to half AT squared, where A is the acceleration and T is the time. The acceleration A of the cylinder down the plane is given by this expression. A equals to GH over L bracket 1 plus I over mr squared, where A is the acceleration due to gravity, H is the height of the inclined plane that you are doing, and L is the length of the journey. Then 1 plus I is the moment of inertia. That is the title of the experiment that I want to determine. Then M is the mass of the metallic cylinder. Then R is the radius of the metallic cylinder. So from equation 2, we make A the acceleration, the subject of formula. Then we have A equals to 2L over T squared. And this makes equation 4. But when we substitute this equation 4 in equation 3, we have, instead of writing A, we write 2L over T squared. So we have 2L over T squared equals to GH over L bracket 1 plus I over mr squared. So from this expression, you can see that the variables we have there is the time that you have taken from the experiment, and the H, the height of the inclined plane that often measured from the experiment. Those are the two variables in this equation. The G is a constant, which is equal to 10 meters per second squared. The L is 100 centimeter, which when converted is 1 meter. 1 is a constant. I is the aim of the experiment we want to determine, which is moment of inertia. M is a constant, which is the mass of the cylinder. And R is the radius of the cylinder. So when you do that, you record all the readings in your table. You record the time for the metallic object to roll down the inclined plane, which I'm going to demonstrate. Then at varying degree, at varying height of the inclined plane. So when you do that one in your table, you now plot the graph of T raised to minus 2 per second square against H in meter. The slope of that graph is what we are going to equate to this expression. G over 2L squared, 1 plus I over mr squared. Then from there, you make I the subject of the formula to obtain a particular value, which is the aim of our experiment. So I'm now going to our experiment proper. First of all, I will determine the mass of this metallic cylinder using weighing balance. This is a digital weighing balance. Then you measure the weight of this mass directly from the weighing balance. You record it. This will give you in gram. You can change the SI unit if you want it in gram or kilogram, but it's better to have it in kilogram, the SI unit. After you have done this one, then you measure the diameter. We need the radius, but you can't get the radius directly. You have to measure the diameter at 2 perpendicular points of this object. I believe you know how to use vernier caliper. In one of our video demonstrations, we have explained how to use a vernier caliper to take measurement. So this is how to use your vernier caliper. After you have inserted your object properly, then you measure from the scales of the vernier caliper. You have two scales. We have what's called the main scale, and we have what's called the vernier scale. The main scale is the one that is not moving, and is from 0 to 25 centimeter. This one I'm holding. The 0 on your vernier will point the reading on the main scale. That is one reading. Then the second reading, you look at the point of coincidence between the main scale and the vernier scale reading. You take that reading on the vernier, then you multiply by 0.01. You add the two together and the unit is in centimeter. So we have gotten our M and we have gotten our R. So you can convert them to M to kilogram and R to meter. So to now start the experiment, so as I was saying, I will start the experiment by rolling down the inclined plane with my stopwatch, using the stopwatch. I already marked my inclined plane. That's the length of this meter, which is 100. I have a stopper. So before I start rolling down the metallic cylinder, I would like to measure the diameter. I would like to measure the diameter of the metallic cylinder. Again, for clarity, I said you have to measure the diameter of this metallic cylinder at two different positions, which is perpendicular. First of all, you measure here. You measure here. You take your reading, the reading on the main scale and the vernier scale. Then you measure here. You take the same reading. The two readings you took, you take the average and divide by 2 to get the radius. So that's how to use vernier caliper. Then the next thing is to now roll down the metallic cylinder. Before rolling down the metallic cylinder, you have to set the h, the height. I'm starting with h equals to 4 centimeter. I'm starting with h equals to 4 centimeter. I can do this one twice. Take the average, take time, T1, T2, find the average of that time, and square the time, and find 1 over t squared, which is what the variables on the y-axis. So this is my metallic cylinder. This is my starting point. This is my starting point. So as I'm releasing, I'm not pushing this metallic cylinder. I'm not to push. I'm to just release it gently while starting the stopwatch simultaneously. I stop my time and I record the time. That time is T1. I'll go back again. Release it. I take the time T2. So you add the two T1, T2 together, take the average, and do further whatever you are looking for. The next one is to increase h to 6 centimeter. You increase h, you take your ruler, measure h equals to 6 centimeter. Then you do the same thing. You release it. Can you see? This is not good enough because it's supposed to hit the stopper. Good. So this is how to do it. So you have to obtain several readings for H. H is equal to, we start from 4, 6, 8, 10, 12, like that. You have like 5 to 6 readings. Then you plot the graph and determine what you have explained on the board. Thank you very much. You see further questions in your manual to answer.